Today we're talking about the geometric sequences, and so this warm-up will help us out a bit. If you're not sure how to plug these into your calculator, that's one thing that I want you working on a bit right now. Something you can do in your head. If you're not sure how to plug them into your calculator, make sure you call me over and get some help on that as we're working on this part. Okay? Okay, so I had a bunch of you ask me on this. On most of your calculators, you're looking, if you're trying to put 2 to the 5th in, you're going to enter 2. And then you need to find the caret symbol. It's this arrow that looks like that. Okay? So you push 2, that, and then 5, and that should kick out an answer of 32. Because 2 to the 5th means 2 times 2 times 2 times 2 times 2. 4, 8, 16, 32. Okay? So rather than multiplying by 5, you're raising it to the 5th power, which means you're multiplying this number by itself that many times. So 2 to the 5th. Okay, so if you have a different calculator and you're still not sure, call me over. I'll help you out. Okay, let's check it out. 2 to the negative 5th. Hey, if you're putting this one in your calculator, just make sure that you put that negative 5. It's always good to put it in parentheses. It's a good habit to get into. Okay? So 2 to the negative 5th, what do we get there? Oh, a bunch of you had decimals on it. 0.03 125. And in fraction form, if you change that to a fraction, it was, what was that, Dan? What was that fraction we came up with? The 5. Oh, a different one. That was over here. Okay. Anyone have that as a fraction? What do you got, Kay?
1/32.
Yeah, it's 1/32. Good job. That's the same thing as 1/32. Just like 2 to the 5th is 32, 2 to the negative 5th just puts that 32 on the bottom. Just moves it to the bottom. Okay? So negative 3 to the 4th is a bit different. This one actually, if you put it into your calculator, many of you probably got 81 or negative 81. How many got negative 81? How many got 81? Okay? Good. So this is sitting here, this negative sign, since it's not inside of parentheses, you're not raising negative 3 to the 4th power. You're only raising 3 to the 4th power. So here we're saying this negative sign is like having a negative 1 hanging out there. So it's negative 1 times 3 times 3 times 3 times 3, which is negative 81. Now if you put it into your calculator like this, if you just put negative 81, or excuse me, negative 3 to the 4th without parentheses, it should have given you negative 81. Okay. So if this is negative 81, what's this one?
81.
Yeah, this one's 81. This one says the difference is negative 3 times negative 3 times negative 3 times negative 3. Because it's in parentheses, you're raising the whole piece to the 4th power. So, good, yeah, that makes a positive, and that makes a positive. So we get 81. Well done. Any questions there? All right, let's check out number 5. 2/10 to the 3rd.
I got 0.008.
0.008. How many got that? That's very good. Good. That's 8. That's 8 over what? How many know how to change this? Does anyone know how to read that? What's it say? 8 thousandths. Good. Okay. Notice how many, it's a base 10, so how many numbers are behind the decimal? 3. So that means your denominator is going to have 3 zeros in it. A 1 with 3 zeros. 8 1,000ths. Okay, which is 4 500ths or 2 250ths or 1 1/25. Okay? Here, 7 times negative 4 to the 2nd. Got to do this part first. Negative 4 squared is 16. So we get 7 times 16, which is? What's 7 times 10? 70. So 16 is 10 plus 6. So 70. And 7 times 6 is? 42. So 70 and 42 is? 112. Good. All right, here we got to do the power first. Okay, so this gives us 1 to the third power and 3 to the third power, or 1/9. And we're multiplying that by 15. So we get 15 times 1/9. It's 15 ninths. Yeah, put a 1 under it. Get 15 over 9. What goes into both 15 and 9? 3. How many 3s here? 3. And how many 3s here? 5. So we get 5/3. For those of you who did it on your calculator, you probably get like 1 point, what?
I got 5 minutes.
Yeah, 0.5 repeating.
0.5 repeating?
Yeah, so one.
0.555?
I got 5 nines.
You have 5 nines? All right, so I didn't get this. So where do we make a mistake here then?
It didn't divide by 9.
I didn't divide by 9?
Yeah, calculate.
Dude. Oh, I messed up right here. Anyone see my mistake? I see my mistake now.
Oh,
You put the 15 in?
No, it's up there. It's right here, from here to here.
Cube.
Heather?
Cube.
you, this. Shit, I forgot.
Ethan?
You did 3 to me, did the second.
Yeah, 3 to the second. I need to do 3 to the third. This should have been 27. That's my fault.
Oh,
Unbelievable.
sorry, I was right.
Could have been right. That should be 27, which makes this 27. How many 3s go into 27? 9, which makes this 5 nines. Hey Dan, that's the one you had. Yeah.
I got that.
All right. That's better. How many knew I made a mistake right here and just didn't say anything? Thanks. All right. -4/10 to the third power is -4/10 times -4/10 times -4/10. Negative times negative times negative is the positive or negative? That's negative, yeah. So negative, what do we get there? 4 times 4 times 4? What's that?
0.768.
Oh, that's times 12, right? Let's get just this part first. So we get negative, it's 4 times 4 times 4? Thank you, 64. Okay, so 0.4 times 0.4 times 0.4? 0.064. Good. Negative 0.064 times 12. KK.
0.768.
0.768. Positive or negative?
Negative.
Negative, yeah. Because we have negative times positive. All right. That's 768 thousandths, right? 10 thousandths? Tenths? Hundreds? Yeah, 1,000ths. 000. So 768 over 000. Put a 1. And then we could reduce it. Pretty blurry there. All right. Any questions on the warm-up? How many feel more comfortable putting it into your calculator? Going to be using that a lot, this one. Okay? All right. Hey, so geometric sequences. Here are our objectives, our learning goals. Get those down there. 11-1 isn't, this is not our book section. It's just, this is not in our textbook. So that's why we're using a different set of stuff here. All right, so we're going to do geometric sequences. What was the last sequence we studied?
A.
Good. Arithmetic. Okay, the arithmetic sequence there where we're adding every time. Okay? In a geometric sequence, we're not going to be adding every time anymore. So those are the two vocab terms we want to define today. So make sure that you put those into your notes there. So as we're going through, you can add those. So I'm missing Brina. Right. And Anya. Thank you. And Taylor. So, geometric sequence. All right. So the table shows the height of a bungee jumper's bounces. Anyone been bungee jumping? No one in here has bungee jumped? You have? Really? How high were they?
It was scary.
Was it scary? Did they have to push you? Really?
Like off the bed, yeah.
Were you like, I'm not jumping, and they just like gave you a shove? Dude.
That was crazy.
Yeah.
Have you seen that video of the prank against their friend where they're jumping, bungee jumping, and his friend was already tied off to the cord, so they had a spare one. So when Beyonce threw it, like, oh no,
Oh no.
and he scared the crap out of him.
Oh, that's so mean, man. So will you go again, Kalina? Wow, that's intense. All right. Well, this this table shows the number of bounces and the height in feet after like you bounce that much. That's
Pretty cool.
geez, man. Okay, the height of the bounce is shown in the table above the geometric sequence in a or from a geometric sequence. So we have this geometric sequence. The ratio of successive terms, the same number is the same number r, called the common ratio. So when we're dealing with a geometric sequence, we're dealing with a ratio, and ratio means like a fraction, but we're going to think of it as multiplication here. So if I'm going from here to here, and then here to here, okay, rather than looking like when we're doing an arithmetic sequence, we're looking for a common difference. Here we're looking for a thing we're multiplying by every time. And when you say from 200 to 80, that's tough to figure out what that is. But if you take and divide this by this, so if you say, okay, well, I'm going to call this 80, okay, 80 200ths, and then divide this by this, I'm going to call this 32 80ths. All right, and then we reduce. Okay, so 80 200ths. Everyone go ahead and reduce that right now. And 32 80ths, reduce that.
It's at 25.
Huh?
I think it's wrong.
So this one, 8 goes into 10 times. 25. 10 25ths. Okay. This one become 10 25ths? No? This one just becomes 2/5? So you took 8 out? Or 16 out? It's like 16, right? You can keep cutting in half. For those of you, you're like, well, I know that 2 goes into both of those. That becomes 16 and 40. And then I can cut that in half again. That becomes 8 and 5, or 8 and 20. And I cut that in half again. That becomes 4 and 10. And then 2 and 5. All right, and I can't cut it in half anymore, so I'm done. So it's 2/5. Well, we're supposed to have the same number. That's 2/5. That's 10 25ths. What's the problem there? Ethan? Yeah, we could reduce 10 25ths. What number goes into both 10 and 25? 5. 5 goes into this twice, and this 5 times. So our common ratio, the thing it's going up by every time, is 2/5. You're multiplying by 2/5. Yeah?
Wait, how did you get 25?
We divided 80 by 8 and 200 by 8. Yeah, we divided them both by 8. How many of you know how to reduce on your calculator? Oh, that's a good skill. Especially if you don't know how to do it by hand yet. It's good to know how to do it by hand, but I'll go through that and try to help you out with that. You guys got to tell me when that's blurry. I can't. I don't know what's up there. All right? So this is our common ratio. What you're going up by, what you're multiplying by every time is our common ratio. Okay? All right. So I want you to take, we've talked about this. Remember, each time we're going through this, the first term is called A1, A2, A3, A4. Tell your neighbor what the common ratio between 3, 6, 12, 24 is.
That goes up by 3, that goes up by 6, that goes up by 12.
What's our common ratio?
Basically multiple.
Yeah.
Multiplying by 2.
Yeah, you're multiplying by 2. Okay, you're multiplying by 2 every time. Times 2, times 2, times 2. So in a geometric sequence, you're not adding, you are multiplying. And the thing you're multiplying by is our common ratio. Okay, so defining those pieces, a geometric sequence is when you're multiplying by the same amount every time, and that amount you're multiplying by is our common ratio. Right. So knowing that, we've already done that. I want you to take a look at this guy right there. Find the next 3 terms in that geometric sequence. Work with your partner there. By dividing each term by the term before it. So if we go 4 divided by 4 divided by 1, 16 divided by 4, 64 divided by 16, each of those equal 4. Or if you say, what am I multiplying every time to get the next one? That's pretty easy in this one. Right? These numbers are easy. You go, well, that's 1 times 4 gives me 4, and 4 times 4 is 16. How many got that R is 4? Okay, so the next 3 terms we just multiply by 4, right?
Yeah.
Okay, Caleb, what do you get for the next 3?
I got 256, 984, and 3,936.
Cool, so 256 is right. I'm not sure 984, unless my PowerPoint's wrong. Is it 1024?
Yeah.
Maybe double check. And I think that threw off your third one because of the second one.
I did it wrong.
Okay. So 256, 1024, and 496. All right, 4096. Now, in order to do this, what we use, you guys remember the recursive formula? Recursive formula when we are doing arithmetic sequences, we took the previous term and we added d. When you're doing a geometric sequence, this is your recursive formula. The recursive formula, remember, is the formula that you really don't actually ever write out much. The recursive formula is right here. A sub n, so the next term is equal to the previous term times r. Okay. A sub n equals a sub n minus r times r. Actually, this should be a sub n minus, that should be a 1 right there. That's wrong in the PowerPoint. This should be a sub n minus 1 times r. So to find this term, we've got to take the previous term, which is a sub n minus 1, and multiply it by our r. Remember, the 4 is our r. So to find the 1024, or to find 4096, you take 1024, the previous, and multiply it by r. Okay, so that's a recursive formula. Let's give this next one a shot. All right, work with your partners. That one's a little tougher. Ready, go. Hey, what is our ratio? What are we going up by every time? Negative 1/3? Negative 3?
Dividing by negative 3.
Dividing by negative 3. So when we divide by a negative, notice it's negative because we go negative, positive, negative, positive, negative. That means you're dividing by a negative. That's the only way to flip your signs. Okay? So we're dealing with a negative. If you can recognize you're dividing by 3 every time, dividing by 3 is the same thing as multiplying by 1/3. Okay? So we're multiplying by negative 1/3. We don't want to know what we're dividing by. We want to know what we're multiplying by. And if you couldn't have figured that out, if you didn't figure that out, you say 3 divided by 9. Negative 1 divided by 3. 1/3 divided by negative 1. 1/9 divided by 1/3. All of those should have given you the common ratio of negative 1/3. So to find that ratio, divide this one by that one. So r equals that. All right. So if we want to find the next 3 terms, what are the next 3 terms? Boy, oh, we got you already. Amanda, what do you got?
I only got the next.
The next term, what's the next term? 127. Good. So multiply the bottom by 3. All right, Dan, what's the next term?
Negative 181.
Okay, negative 181st. All right. What's our final term? Zach?
1 over 243.
Good, 1 over 243. Well done. Notice it alternates between positive and negative. All right. Any questions there? How many think you got it? Okay. Very good. I want you to take a look at. I already got that one. I want you to take a look at that one. Just tell me what the R value is there. Okay? You don't have to find the next three terms. I just want to know what the ratio is. Okay, what's the ratio? Yeah, what do you got? Negative 2? Austin, is that what you got?
Yeah.
How do you know it's negative?
Because negative times positive is negative.
Negative times positive is a negative. And each time, notice that these are alternating. That's going to tell us that R is negative 2. Okay? All right. Hey, let's move on to the explicit then. All right, so in your notes, go ahead and now write down the explicit formula. We're going to take a pattern and kind of figure one of these out here. Okay? Explicit formula. Get a piece of paper that you guys can't see through there. There we go. Remember, the explicit formula helps you to find the next term. Or not the next term, but a specific term. So for instance, if I gave you, say, 3, 6, 12, 24, and so on, if that's my pattern, okay, what's my common ratio there? Times 2. Okay. Pretty easy, right? Multiply by 2 each time. All right. Okay? This is called A sub what? A sub 1. This is A sub 2, A sub, and A sub. Okay, let's say I want to find A sub what? 15. Okay. Well, let's go 40, yeah. It's further out there. 15, we could just extend it, right? But A sub 40. All right. So we're trying to find A sub 40. So notice to find if I know A sub 1, I'm starting there, and say I want to find A sub 2, I just multiply it by 2. If I want to find A sub 3, I multiply it by 2 how many times? Yeah. If I want to find A sub 3, I'd multiply it by 2 twice. 2 different 2's, right? But if I want to find A sub 4, by 2 by 2 by 2. What happens if I want to find A sub 5? How many 2's? 4. 2 times 2 times 2, right? What if I want to find A sub 6? Okay, so it gets kind of redundant when we say 2 times 2 times 2 times 2 times 2. And if we want to find A sub 7, it's 2 times 2 times 2 times 2 times 2. How many 2's is that? 6. Okay, repeated multiplication of the same thing, that's a power. So this is 2 to the first power, this is 2 to the second, this is 2 to the third, this is 2 to the, and this is 2 to the, and 2 to the 6th. So tell your neighbor, if you want to find A sub 1, you're going to multiply our ratio, right? This is R. We're going to multiply our ratio how many times? If I just want to find this. If I start out with A sub 1 being 3, how many times do I multiply it by 2? Yeah, 0 times. 2 to the 0 power. What is 2 to the 0 power? Is it? Everyone on your calculator, hit in 2 to the 0. We know Dan knows. Okay, what is it? 1. Yes, very good. It's 2 to the 0 is 1. This will give us an answer of 3. All right? What if I want to find a sub 2? I'm going to start with a sub 1 again. How many times am I going to multiply by 2 to get here? How many times? One time. Okay, that's going to give me 6. If I want to find a sub 3, I'm going to start with a sub 1. How many times am I going to multiply by 2? Everyone agree it's 2? Okay. 2 squared is? 4. 4 times 3 is? 12. Okay. Let's say I want to find a sub 4. I'm going to start with 3. How many times am I going to multiply by 2?
3.
Yeah, to get to a sub 4, I'm going to multiply by 2 3 times. 2 to the third is?
24. 12. 8. 8.
It's 8. 8 times 3 is 24. Okay, there's our pattern. If I want to get a sub 5, how many times am I going to multiply by 2?
4.
Okay, everyone tell your neighbor what's happening in the pattern. Okay, what's the one thing that's changing every time? Is A1 changing? Is R changing? Well, the little power thing's changing. So the little power, is it in? It's n minus 1. N is 1, right, here, but that's 0. Here n's 2, but that's 1. Here n's 3, but that's a 2. Here n's 4, but that's a 3. Here n's 5, but that's a 4. As Amanda said, it's n minus 1. Okay, that is your explicit formula. A sub n, whatever thing we want to find, is equal to a sub 1 times r to the n minus 1 power. This is your explicit formula. What's that?
What you just said, whatever you want to find.
If you want to find a specific power, to find a specific power, or to find a specific term, you've got to use this formula. So if we started out by saying we wanted to find the 40th term, a sub 40. Using this formula, I want you guys to find a sub 40. You got it already? All right, let's give everyone a chance to find it. All right, what is it, Randy?
4,563.
Good. So 4,563 is what Randy got. Okay, remember R here is actually 2, so we get rid of that R. We'll put 2 to the 39th power, the n minus 1. Is that not what you got?
I got weird.
You got a weird answer?
You just got a big number, Charles.
Did
I got 1.6492697442.
yeah, that sounds a little more accurate.
Zeros.
Yeah, it's going to be huge, right? Did anyone get it in scientific notation, like at the end it said E, or it gave a little power?
Yeah.
You got that?
Power
Do you have it on yours, Marley? No. You got it on. Let me borrow. Can I see how to use it? Okay.
You do like this.
So look, we get you can get two different looks at it. This one right here,
Oh, that's right.
that's scientific notation. Notice it says times. At the end here it says times 10 to the 12. So this is 1.6 times 10 to the 12. And then here's another way you'll see it on a calculator. They won't show the times 10. They'll put a little e. That just means times 10 to the 12. Okay, but either way, 1.65. Let's write that. So this wasn't quite right. 1.65 times 10 to the 12th power. Okay? Tell your neighbor what that number means. Thank you. Hey, for those of you who don't know what that means this. You can't remember scientific notation? That means 1.65 times 10 to the 12th means you move this decimal over 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And all these other blanks. Now on the calculator it showed a bunch of numbers, so you could have kept those numbers. But for the sake of what we're doing, it'd be 165 and then that's the number we're looking at right there. That's huge, man. That's million, billion, trillion, quadrillion, dude. 1 quadrillion, 650 trillion. That's a big number. Man. It's bigger than our national debt. Shoot. Not too many, I know, not too many things bigger. All right. Scary, I know. All right. Hey, any questions there? All right, I want to do one or two more problems with you guys, and then we'll call it good. Okay? So, I hit all the stuff from me here. All right, try that one there. First term of geometric sequence is 500. The common ratio is 0.2 or 2/10. What's the seventh term? Try to use your explicit formula. You got it?
Are we gonna create a common?
Yeah, we will.
Wait, is this correct?
We're going to find out. Okay, there's our explicit formula. In order to use the explicit formula, I need to know a few things. First, I need to know what n is. I need to know what r is, and I need to know what a sub 1 is. What is a sub 1? Yeah, it's 500, the first term. What is r? 0.2, and what's n? Yeah, it's 7 in this case. So when I'm finding a sub 7, or the seventh term, that's equal to a sub 1, which is 500, times r is 0.2, to the n minus 1, or the 7 minus 1 power. Okay? Now, remember, this doesn't mean much of anything for us. It's just telling us seventh term. So we don't have to do any math here. So I'm just going to bring this down. Say 500 times 0.2 to the 6th power. What'd you get, Randy? 3200. Nice job. They look like that? No? Other one? Decimal here? Yeah. Okay, so like that. Yeah, good. So that's 32 thousandths, right? Tenths, hundredths, thousandths, or 3 zeros would be 32 thousandths. Good work. I appreciate you trying to read it off there. How many got that? There we go. Hey, any questions? That's what we got today. So now tell your neighbor the difference between arithmetic sequence and geometric sequence, please. Okay, volunteer, what's the difference between geometric and arithmetic? KK, what's the difference?
Arithmetic, you're adding, and geometric, you're multiplying.
Very good. Arithmetic, you're adding. Geometric, you're multiplying. They both have explicit forms we use. Nice job.